Hello guys, welcome back to another episode of Learn Smart with Faith Olasayinde, and this time we're going to be treating how to name hydrocarbons. I'm going to be starting with alkane, then going to the alkenes and the alkynes. Alkane. This is a homologous series of saturated hydrocarbons. They have a general formula CnH2n plus 2. Yeah, so that means the first member just add 1 as N, and then you get CH4. And this is called methane. The next member, C2H6, that's called ethane. The next member, propane. The fourth, butane. And from the fifth onward, you use the idea of polygons like pentagon, hexagon, octagon, and so on. So that means the fifth member here would be pentane, the sixth hexane, the seventh heptane, the eighth octane, the ninth nonane, the 10th decane, and then it goes on and on like that, undecane, duodecane, and so on. All you just have to do is have the idea of how polygons are named. The alkene. This is an homologous series of unsaturated hydrocarbons. They have a general formula CnH2n. The first member does not exist. So that means the next member is ethane, C2H4. By the time you put 2 there, you get C2H4. Then the naming goes downward just like that of the alkanes. But the unique thing about alkene is the presence of double bond. Taking ethene for example, it is CH2 double bond CH2. The alkyne. This is an homologous series of unsaturated hydrocarbons, more unsaturated than the alkenes thanks to the presence of the triple bond. The first member is the ethyne, and the name goes down as usual. Now the question is, how do you name a complex structure? Well, let's try a few examples. Let's try this. To successfully name this, we need to follow some rules, and we can see that there is no double bond or triple bond, so we can be sure that it is an alkane. It has an attachment that is chlorine. These are the rules. First, count the longest carbon-to-carbon chain. Well, most of the questions you will face in your exams are going to be skeletal structures. One edge means that there's a carbon there. It's just like the normal structure that you know, except that the hydrogens are hidden. Well, we are going to have a video to explain so much more about this. But for now, let's know the rules. After you have counted the longest chain, then start to number. But for alkane, you have to number from the side that gives the smallest number possible for its attachment. In this case, if you start numbering from the right, you will have chlorine being an attachment on the fourth carbon. But if you start numbering from the left, the chlorine is attached to the second carbon. And I will start numbering from the left because it gives the smallest number for the attachment. So this compound is named 2-chloropentane. The longest chain takes the parent name, which is pentane, and the attachments are placed before with the number of the carbon where they are found. 2 in this case means the chlorine is found on carbon number 2. Let's try another. So we can see it's still an alkane, right? There is no double bond or triple bond. And the longest chain here is how many? 5, yeah. Then the attachments here are what? Bromine and chlorine. Numbering it the best way should be from the left. In this case, it will give 1 bromo and 4 chloro, right? But if we number from the right, it would give 2 chloro, 5 bromo, which is far higher than the first one. So we're going to settle for the first, since the rule is that pick the one that gives the smallest number possible when naming an alkane. The answer for this is what? 1 bromo, 4 chloropentane. The whole numbering game changes when it is an alkene. Take for example this. In the case of alkene, after you have determined the longest chain, double bond takes the preference of counting. That means you have to start counting from the side that is closest to the double bond. It's quite much easier than the alkane, right? The only thing is that you have to tell where the double bond is. And in this case, you can see it after the first carbon, right? So it's on position 1. Then the parent name goes pent 1 in. The one there tells that the double bond, which is the in there, is on carbon 1. The same goes for the alkyne family, except that the name ends in -ine. So whatever rules that goes for the alkene also goes for the alkyne. The only thing is that the name changed to -ine instead of -ine in the end. Before I round up, there is this group of hydrocarbons that are called the alkyl group. They are usually found as an attachment and they are just like alkane, except that they lack one hydrogen, that's CnH2n plus 1. So that means the first member is the methyl. They are usually represented as R in most of the functional groups that you see. The point is that sometimes you see them attached to your hydrocarbon, just like in this case. This one is CH3, so it is methyl, but it's found on carbon 2 on this hydrocarbon. To name this hydrocarbon, it is what? 2-methyl butane. And it is butane because by the time you count the parent chain, you have how many of them? You have how many carbons? 4 carbons. So butane. Well, anyways, I hope you got this one. This video is just majorly to explain the rules. It is just setting the basis for many videos to come. In videos to come, I'm going to explain deeply on the things you have to take note of in order to get your answers correctly in exam. It's not just about knowing how to name them, it's about following the rules. And after that, we cover many other functional groups. I remain Olasende Faith, and until I see you in the next video, peace.